Hi, my name is Sathira Anil and I am from College of Engineering Trivandrum, India, and I'm going to present on the topic Micromobility Integration in Indian Urban Spaces, a case study of Whitefield, Bangalore. So these are the abbreviations that I am going to use throughout this presentation. So, the world is transitioning towards a public transit oriented landscape, and there is a need to reduce global carbon footprint. A new emerging solution to sustainable transportation was introduced in the late 2010s, where shared electric vehicles are used for commuting. This new mode of transportation is called micromobility. What is micromobility? Micromobility vehicles are small electric powered option for short urban travels, and they are scattered across the city for anyone to use, forming an advanced bicycle sharing system. So the main potential of the study is to explore integration of micromobility into Indian transportation system. That is, India has a strong public transportation infrastructure, but they lack in micromobility solutions. Benefits of integrating micromobility increases sustainability. That is, major cities in India are already suffering from excessive pollution as shown in the graph, and over 40% of the oil and oil products are used up in the running of vehicles. Improved connectivity solution, that is micromobility in urban areas has significant potential to address first mile and last mile challenges, enhances access to public transport. Impact on future street. Future cities will feature multimodal transport system where various modes are going to compete for space, and there is a necessity to design this future spaces. And related theories. Theory of land use transport interaction. There is a two-way interaction between urban land use and transport. The distribution of land use determines the location of activity, and transportation systems can directly change built environment at the node and link level. Research questions include: how were cities globally implementing micromobility? How have Indian cities implemented micromobility and its contribution in the city? How does the implementation and regulatory framework of micromobility differ globally and with India? And what factors contribute to these variations in the adoption and management of micromobility solution in urban environments? So the objective framework, like research questions are used to derive objectives, which will be described in next slide. The aim is to understand the key factors influencing the adoption and management of micromobility solution in diverse urban contexts in India. We are using comprehensive comparative analysis method. Objectives include: analyze the strategies undertaken by cities worldwide to implement micromobility, analyze the strategies undertaken by Indian cities to implement micromobility, investigate the challenges faced by Indian cities in integrating micromobility into existing urban system, identify commonalities and differences in approaches taken by both, and do a comparative study, formulation of design strategies. Methodologies. The action plan was derived for each objective. This includes selection of literature studies and literature case studies, and identify parameters from this literature studies, and using these parameters a live case study was analyzed, and expert interview, qualitative survey, etc. were done, and all of this is done in order to finally reach a comparative analysis, inference, and a conclusion. These are the parameter: built environment, design standard, accessibility, demography, distribution, and imageability. Study is Whitefield, Bangalore. Why was Whitefield chosen? Is because it already has a dedicated micromobility solution accessible by the general public, and the area also has a growing market for this MMV vehicles. And the area has mixed nature in demography, and there is a lot of public transportation, which include metros and public buses that are being used by these people. So that is why Whitefield was chosen. And when studying the area of Whitefield according to the parameters, first one is demography. We can see that there are it can be divided into two, that is for work and for leisure. So for work, which means that the people like delivery guys, etc., uses this micro mobility vehicles because it is actually cheaper than using their cell phone vehicles. This is the distribution map according to the land use. We can say that there are a lot of micromobility hubs available in the metro area, and next to the main roads, etc. But as we move away from the main roads, the number of hubs also reduces. And in this the number of hubs in the residential area is much lesser when compared to the that of the commercial area, but it is not a very efficient method of distribution, because if we don't have a micro mobility vehicle available next to our home, we will obviously use our cell phone vehicle to reach the commercial area and to reach the workplace, etc. So um, the first mile solution should be cleared before we are moving on to the last mile solution. So parking, there is an issue of not having a dedicated parking, and it actually disrupts the pedestrian pathways as well. And so it is best for parkings to be a bit away from the roads, pedestrian footpaths, etc. And doesn't have a dedicated lane, and there are no barriers, etc. So it shall be provided for, if in order to make it more safe, the usage of micromobility vehicles more safe. So there is illegal crossing of lane, compromised use, wrong side, etc. being done. And accessibility, we can say that this most of these micromobility vehicles are being marketed for these workers rather than the pedestrians. So there is a less availability of these vehicles, and it is not visible in the area. The hubs are not visible. It's just a two-dimensional entity, and there is no attractiveness, there is no visibility factor, etc. to these hubs. And there was also another observation, which means that these hubs are not integrated with the built environment. It just, there is no street furniture, and there is no human activity or human interaction happening. So in order to uh, overcome all these issues, we can say that there are a certain design strategies can be implemented, which includes the decentralization, that is integrating this hubs into the built environment and into the building complexes, and creating opportunity for human interaction, etc., surrounding this hub. And creating public buildings that has micromobility vehicle accessible lifts, and providing showers, etc. Like if a person is going to use this micromobility vehicles on a daily basis, like the bicycles, etc., they need to have a shower, they need to have a changing room, etc. So that can be provided in the public spaces as well. And parking bays can also be provided in the buildings, etc. And parklets, racks, and corals, etc., can be given in the hubs, so that there is a visibility factor, there is an actual form to this hubs. And in order to the it shall not disrupt the pedestrian pathway, so the parking can be initiated into a corner, and things like that can be done. So the in order to make this use of micromobility vehicles more safe, we need to have color coded lanes. There can be symbols, there can be slow streets, etc., shall be provided. Then we need to have shades, and we need to have trees and bushes, etc., so that the drive may be more pleasurable. Then decentralization of the hubs can be done, like it shall be distributed among the paths and among the buildings, and at least one hubs can be provided every 100 meters. And colorful signages, ramps, interactive maps, ticket vending machines, etc., can be given, so that it is more visible, and affordable fair prices according to Indian markets, etc., shall also be given. And multiple types of micromobility vehicles that can cater to the needs of different types of people shall also be provided, so that many people find it easier to use this micromobility vehicle. Then it shall be given, the hub shall be given a proper identity, human activity. It can, thus it can act as a landmark, and improving of the connectivity towards the nodes, creating more links, etc., can also be done. And the minor spine, instead of focusing on the major spine, the minor spines and the minor nodes can also be identified, so that the distribution of these vehicles is more practical and more efficient. And although the in conclusion, although exists in Whitefield, it is not designed very effectively and not integrated well with the built environment of the city. So the present implementation lacks thought and is not visible and imageable, making it a niche transportation with limited adoption. With better design solution, careful planning, and improved availability, the current network can become a more robust transportation system with increased adaptivity. Thank you. That's it. Thank you very much.